Okay, now let's continue. The next substance is salt, right? The chemical name of it is sodium chloride. Okay, because we have the sodium cation plus and the chloride anion minus when it dissociates in a water. Okay, so we can see that sodium here is also a alkali metal, which from a very strong base. So from a strong base, then it should have negligible acidity. And also like for chloride, it also from a very strong acid, which is the hydrochloric acid. So then it's also not a basic anion. So then both of them just like neutral, okay? So that's why the solution of salt is just a neutral one, that it will be classified into the other group. Good. Now, as we have mentioned about chloride already, it just reminds me of the halogen group, right? So if you remember in the halogen group, we should have F, fluoride, and then we have chloride, and then we have bromine, and then we have iodine, right? So going downward in the periodic table, in the same group 7A, the halogen group, then we can see that the sign increasing, right? So we can see that for the bond between the hydrogen and the fluorine, it should be shorter compared to that one of the hydrogen between this hydrogen and the iodine ion. So that's why we can see that this one have a longer bond, and for a longer bond it should be a weak bond. So that's why the hydrogen here can be easily dissociated from the substance much than in the HF, and that's why HF is considered as a weak acid, while from the hydrochloric acid, and this is the this one is a hydroiodic acid, is a strong one. Okay, then we also go with this one and this one as well. Okay, let's have a look at this one. We also have it like H₃PO₄. So what is it? Okay, so actually if you're familiar, this one is a phosphoric. It says the name phosphoric because it has to do with phosphorus acid. And we can see that there are three my bad. There are three hydrogen here in the structure of phosphoric acid. So that's why it can give away 3 protons. So it's a triprotic acid. But it's actually a very weak one, okay? If you have a look at this one, you can see that if this is more to learn about this one if it's not phosphoric acid. So if you want to have a look, you can have a look at this later, okay? Just pause the video and I will let you have a look at it. If you have questions, we can discuss, and please let me know in the comment section. But basically this is a phosphoric acid, triprotic acid, and it's a really weak one, okay? So this is just a weak acid, H₃PO₄. Okay, next we have another one, CH₃NH₂. So what is that structure? I have this here for you to have a look. Okay, so is it a nonpolar or polar structure? The answer is it's a polar molecule. Why? Because we can see here we have the carbon bond with the 3 hydrogen. It is single bond, and then it have another single bond that bond with the nitrogen. For the nitrogen, actually for nitrogen it will have like 5 electrons on the outermost shell. So then you can see there will be a lone pair here. And nitrogen itself, the atom is also more electronegative compared to the carbon. So that's why it's also like draw more electron towards it. And that's why you can see that more electron cloud here is a rich electron cloud at the nitrogen atom. That's why it can draw more plus towards it, right? It means that it has a tendency to accept proton, and that's why this one will act as a base. That's right, it will act as a base, and actually it will just a weak base. Okay, let me move it there. So this one is just a weak base. Let me move it up here. We have this one here. Okay, that's the metal amide. Okay, this one, metal amide CH₃NH₂, and it's just a weak base. Okay, we have two more to go. Oh, now you can easily see this one here, right? Okay, this one is just a very strong acid. Okay, this is the nitric acid. Okay, and now we have the last one here, ammonia. Let me find some space here. Okay, I will just write down here, right? Okay, so for ammonia, actually again for ammonia, you can also see that there's a lone pairs of electron around the nitrogen atom. It also means that it has the tendency to attract proton towards it, right? This is negative here. So that's why it's also a base. And when you write it, the reaction, it should be this one plus with another proton in the aqueous that will be from another cation. This is ammonium. Okay, and this is ammonia. Okay, so this one is actually a weak base. Okay, yeah, so I guess that's everything, right? Okay, so again here, barium hydroxide, strong base here. Acetic acid is a weak acid here. Salt is a neutral. Lithium hydroxide, a strong base. Phosphoric acid is a weak acid. Hydroiodic acid is a strong acid. Methylamine is a weak base. Hydrofluoric acid is a weak acid. Ammonia is a weak base. And finally, nitric acid is a strong acid. Okay. And I also summarize everything related to how we can determine a cation if it have a really large ray acidity or not. Also the same for anion, if it have a basic property or not. So just have a look at the summary and let me know if you have any question. Thank you.